So good evening, everybody, and welcome to our fifth installment in this data mini-series of NI data. My name is Michael, Natural Intelligence, and a couple of words about us before I let Danny take it. Natural Intelligence, we're a global leader in multi-vertical online comparison. Our matching technologies enables consumers, you and me, to take confident purchasing decisions in various areas and allow brands grow their business. Basically what it means that we build comparison websites, and we have a pretty cool vision. We are building the comparison website of everything. And so imagine any kind of a service you can think of, online services, from dating to loans and through mattresses and even meal delivery. We're touching every such verticals, all of those verticals, and 10 years. We're about 400 people. From day one, we've been cloud-based and on Amazon, and we're running millions of users, and we wrote our own platforms for building those web comparison websites. And our technology stack is, as I said, Amazon. We have a platform for content management and site serving based on Node and Mongo. For our data part, which is, as I said before, holds a big part of what we do, because we want to build the best optimizations and experiences for the users that are searching for services. We're highly driven by data, and for that we've built data platform, a data lake, which is built on S3 and Spark and Kinesis and Kafka and Redshift and Glue and Airflow, and we're doing it all with Scala and Java and Python, and we're pretty much buzzword compliant. And as I said, this is the fifth installment of our mini-series on natural intelligence data platform, data technologies, and the last one for now. I'll do a quick recap on what we already covered, and you can find those videos on our YouTube channel, Natural Intelligence YouTube channel. AVM, the data tech lead, did some intro for data lakes. I did the intro or some kind of a coverage of the data platform that we built for Natural. Chaya, our data infra team lead, did a session on how we moved from our legacy data system to our new and shiny data platform. And AVM, our tech lead, added the additional layers of, let's call it, production grade tools for machine learning and writing ETLs that we built on top of those, let's call it, advanced AWS-based data platform. And today, we're going to cover another area, a little bit darker area, the dark data. And just to give it a big highlight, and Dan is going to dive into the details. Once you dive into handling data at scale, it gets complicated. The data is coming in nested and from all sort of systems, and need to be able to handle it. So if you want to be able to really make use of this data, you need to have some, let's call it, a set of tools in order to handle it. So without further ado, our data tech lead, Daniel, go for it. You should open your...
Yes. You can hear me?
Yeah.
Okay, you can hear me, Amichai?
Yes, go for it.
Okay. So, who am I? Hi, everybody. I'm Daniel Sass. I'm data tech lead at Natural Intelligence. I deal with in last year in data modeling and big data developing. And biking is my favorite, and I find it very exciting. Great. So this is the profile. Now we can go ahead. So what are we talking about today? The dynamic properties concept. And I will try to offer you that dynamic properties concept is legitimate and generic solution because it's actually answer common problem. And now let's see the agenda for that. So first two sections, I will try to clarify the problem and I will present the connection between risk in nested data and dark data. And the last section, we're going to talk about dynamic properties system and how it's tried to answer the problem, and we will examine it in details. Okay, next. So, the risk of JSON nested data. So we all know the benefits of JSON object. They are very easy. They are very easy to write. They are very easy to read. It's easy to shape complex data, means that developer can take a very quick task by JSON APIs and give nice shaping of complex data. It's easy for developer to do it today. And the third one, and the most I like, is it's very easy to link between the two giant, online and offline system. By the way, in AI, we have created this kind of system. We call it event subsystem. So we gather here not to hear about the benefit of JSON object, but to understand more about the problems. So the complexity problem, it can be understood from this actually slide. It's quite a complexity and can give us object is as endless. And flattening deeply nested object can cause performance issues. So we can say that these two problems can attenuate the usage of complex data investigation. And let's see more about that. Okay, when coming to analyze nested data, there are several tools that are available for analysts. The unique tools for Hive, for example, is lateral view and explode function, which is a very good and nice tools again. And Athena also give us a nice function with nice name, unnest function. And Redshift also does some tricks, and I will show you an example after that, what Redshift does actually. But here also we can suffer from same two main problems, complex and long response time. Why? Because when we require from an analyst to try and to work with this function, it can lead or can be tend to complexity and exploding a deeply nested JSON object can lead to long response time for these analysts. So at this point, and as the chart we can see it at the right slide, at the right of the slide, we are on the slope of dark data. So to recap, although these tools provide us a satisfactory analytical solution, they require advanced SQL programming and can lead slow performance times. So now we can speak about what is dark data. Regarding the dark data, please allow me to read two bullets which describe dark data by quoting Maor Kleider, who is the PM of Redshift. So customers storing ever-increasing amount of data, yet only a small fraction of data ever made into the data warehouse. And second one is and I'm starting from middle of the quote, actually from middle of the sentences, but systems available to them to analyze this data were simply too slow, complex, and expensive. So we can see it also, Amazon Redshift also find kind of this problem and gave it a solution. If you're interested, Cleader is the PM of Redshift, and in more specific way, he also responsible about the Spectrum product, and it's, those of you who don't know what is Spectrum, I recommend to read about that. And the nice chart, and the nice blue chart describe it also very well. And you can see that as we get closer to the unstructured data, we enter further into the dark data zone, which this is actually the point. And you agree with me that nested data is under the category of the unstructured data. And from this chart, it's easy to see that nested data can lead us to dark data if we, again, if we watch this chart. So now we understand why it can be risky to analyze nested data. And organization also invest a great deal of time and money to collect data, which, as we said before, it can remain unused. So what next? What can be a solution for that problem? And again, the problem that we said now is we understand that nested data can be potential as for risk because it can lead us to the dark data, and dark data can remain unused. And solution can be, one of the solution can be count as the dynamic property solution. Dynamic property solution can offer an efficient solution for solving the problem of how to effectively use nested data. And let's take a look about that. Okay, first, we will review tables that are used in dynamic property system. Second, we will review the data chart flow. And after that, we will dive into code and example. When I said code, is also including how we have created the main table in Hive. And example of code, it's more like show you example with Scala and Spark. Okay. This matrix, let's review it from left to right. I try to give you the, to consist the rules of each table. So if I'm starting from left, we see the first table. The first table is dynamic props. We call it dynamic props. This is the name that we'll also, we will use in next slides. And I like the idea of nickname. Why I like the idea of nickname? Because by nickname, we can point what is the role in the data flow of each object. So these tables hold the events map data. I'm reading from the first row of the matrix. And who is the table owner? The runtime. So runtime is the guy that will responsible to fill out the data of dynamic props. And do we have a schema change for this table? So the answer is no schema change, usually no schema change. Why? Because we're holding actually a nice object which called map, which hold all the keys that we need in this row. So we don't need actually to add any schema change in this case. And this table will be a JSON a text file, and from JSON type, this is how we said it before. This is how runtime send or keep or persistent the events that created in runtime. Next row is the middle table that I call, the name that I gave here is key value, and nickname is more funny. I think it's garbage in, garbage out. We understood from our customer that whatever you're doing, don't filter out any garbage. We want to see anything that comes from the dynamic props. And we found it very important table because you can see that this table built actually on Parquet, which give us a much better, let me work with this one, much better performance. And again, also here, no schema changes is required, because also here key values still kept as key value. And the last one, but not the least one, is the flattened data. This is the nickname. Who create this table, also the ETL, who refresh the data, also the ETL, and who going to use this data, also analysts and reports. And what's special about this column about this table that we do need to add column when new property comes. This is the idea. So if we're not going to add a column to this schema, to this table, will not be able to expose the new dynamic properties as a flatten, and we will see it soon. Also, this table uses the Parquet format, which is, as I said before, much faster than using the JSON. Great. Let's see the data flow now. Okay, data flow is divided in this case to two. We have the left screen and we have the right screen. Again, it's also similar to where runtime is put the data as independent in offline system, and offline runs independent in runtime. So let's review the flow for runtime. Runtime grab the events from machines and send it to S3. On S3, we can configure the SNS property, and the SNS knows to actually invoke Lambda function. And Lambda function is where we want to be, because Lambda function enables us to write exactly what behavior we would like to do when a new file will be persistent by runtime. So in that Lambda, we will use actually the simple code of add partition. And that way we will have kind of microservice that responsible all the time when new files comes, all the time data will be refreshed. So at the right screen, we see a very simplified chart that describes simple ETL that has simple task to do. Now we need to just read the dynamic properties tables and be able to write the key value table and the flattened tables. It should be quite easy now. Now we describe it as that. Okay, let's see what else. So we are now in a code and example, and first let's look at the details of the important external table, the dynamic properties. Again, let's work with the red one. So bear with me because there are quite a lot of properties here. So first of all, we have created as external table. And in this case, I show you that I have created one property that I name it as data. And I gave the type of struct to this property. What we have in struct, we can find actually the definition of our primary key in this case, which means the ID, the type, and in this case, we call it as a transaction date. And for this primary key, we would like to join all dynamic properties that ever needed. And we call this property dynamic properties and see here the type. Oops, sorry. And you can see here the type of dynamic property, it's a map. So what else we have in this table? We also use the nice concept of a Hive table that call partitions. And let me use it again. And you can see that we choose to use partition and subpartition. The main partition is divided the date divided to look to as a month part of the date. And we also put another partition which hosts or hold the customer name. So in a way, we can say it like that. We have a table. Sorry again. Okay. In a way, we have a table that holds data of customer in date part of months. And for each customer, in the months, we hold all the properties of a customer. This is actually the structure of the tables. And also, you can see here down for the below the command, below the create external command, you can see here how I can use it in Redshift, which is this is actually the nice trick that they did by taking the table as a dynamic properties, left join with the object itself. I think it's a nice trick, and what's important me to share it with you. Okay. So let's see, as I think this chart will lead us to understand the whole story of the solution. It's also, we have quite a lot properties, or details, but let's try to explore it. So first one is the JSON line, and nothing special to say in this case, because it's just a text of JSON lines. And again, you can see here the property, dynamic properties, and the key value that define in that properties. And now, if I'm asking for Spark to run the Spark SQL known command and just show it what you grab from that table, this is what you will get. You will get the output that was named here in this slide as a raw data. And easy to see that for each key, for each primary key ID type in transaction date, we get several properties. And we name it under the one column dynamic properties. And from raw data, we can go to key value data. And key value data, it's kind of exploded tables, because you can see that we spread all the keys and values with its primary key. And this is why we call it key value tables. And look here again, and this table is important because it's actually is based on Parquet, which is faster than the raw data, and it gives us all the data. We don't try to filter out any data, garbage in, garbage out. That's what we said before. But the important here is the flattened data. And you can see that each key that was described here in dynamic properties, also in JSON, we define it as a column. So payout, status, credit pass, etc., call duration, all of them become a column in flattened data. And for each column, you can see the you can see the appropriate property or the value that was also put in the JSON line. So it's easy to see in this slide that we come from a JSON line to a flattened data. Another terms can be the pivot. Pivot does the same things, actually. If someone knows the term pivot, it's flatten and pivot goes together in this case. Okay, let's see what else. For those of you who like to see some code, let's review the Spark code that reflect the output that we saw just the slide before. So here you can see how raw data frame was created. So it's a simple Spark SQL and a query that gave to Spark SQL. And here you can see that I use also a nice function that called explode, which knows to create the key value format for me. It's just one row to create the key value tables. And regarding to flatten, we need to define two more steps. One is to grab the keys from the map object. And second is to declare the primary key. We call it here in the code, this code, we call it as a needed column. So you can see here, needed column is ID, type, and transaction date. And then I can run the last command, which actually know to create the flattened data. So only a few rows in Spark, which is amazing, as I see, to create a very important system, which know to answer the problem of risk nested data. Okay. So in order to make this product an independent working solution, we are missing some requirements actually. And in our case, we do develop some more important things that especially it's belong to data validation. What does mean data validation? We don't want to be at the side that okay, we allow garbage in, garbage out, but until we get to the flattened data. Flattened data must filter or must move via a data validation concept that we can make sure that each data that coming from JSON or the key value tables can be converted to its type. So this is very important step to run in the ETL in order to make sure data that come to flattened tables actually can be read safely by the reports or analysts or whoever. Also, we found that it's very important to manage how flattened schema may be or need to be changed. So again, and this is the important principle in this case, we can run all the system and no data will be available for analysts, because if we didn't change the schema on top of the flattened table, we didn't do nothing. We didn't make the work actually. So we must remember that we need to expose all the new properties in flattened data, and for that we need some tools or other system that knows to change schema and knows to monitor this mechanism. Okay. So, what did we talk about today? So we looked at the risk of nested data, but let me say it again. I don't think that nested data is bad things. Nested data is a great option to shape your data by nested component, or we have a great function that Hive and Athena and Redshift can give us with their strong engine, and we can use it. But all we say here that, hey guys, please be aware that nested data can bring some complexity and some latency in your performance, which in this case, you can find yourself in what dark data say that you're going to pay about this data, but you're not going to use it. So efficient solution can be the dynamic property system. We just described it. And the important one is the map table that using the component of map type. And again, we actually use the key values in this component. And at the end, we going to do the flatten or the pivot of that tables. And we also saw some code and examples. That's it. Thank you for watching today, and feel free to ask any questions.
Okay, guys, so you have the Q&A button at the bottom. Feel free to click it and ask any question you think. I was thinking about a question while you were talking, Danny, so I might ask a question, first. You said that for the part where we flatten the data, we add new columns. Are there any complexities to adding new columns?
So there isn't actually, because this is what is nice about Parquet. You can create any data that you want on Parquet. Let's say you create 100 columns and no one now aware about these columns. And just by adding new column, and then you can export the data. So you actually manage your data separately from the scheme, which give you a lot of options now. So you give all the properties in your scheme, in your data warehouse, but when you require to expose it, you control it. So you just do the non-alter table, add column, and that's it. The data is being exposed to organization. It's very easy, actually.
So for historical data, you're going to get nulls. So the column would be logically there, but doesn't have data, right?
No, again, if we are not going to alter table add column, we're not going to add column to the flattened data, we're not even going to see anything about this column. If we are going to add this column to the flattened data, for those primary key that didn't created any key value, then we will see a null for those primary keys, or for those keys. And I can, if you wish, I can show it again by going back to the example. It's a good question what you asked, by the way. And you can see here, the flattened data here, you can see that credit, or for example, see the flattened data and the column payout. You see that I do have value for one row, but I don't have value for the next row. Why? Because this ID wasn't care even about this key, doesn't know about this key. So this is the idea of sparse, actually. So flattened data can become a very huge sparse table, but I know, and you will see that Parquets know to manage and respond very well to sparse elements, actually.
Okay, and another question I would ask it. We have already some questions, but I don't know off the top of my head. What would be the best way to write those ETLs? You showed Spark code. Can we do it in any other way? You know what I mean?
Yeah, we can do it in other ways. We already show it in the slides that we can use the very nice functions of Hive, Redshift, and Athena. But again, when you're going to use this function, you need to be just aware. You need to be aware that your source is JSON, and data and you can find yourself with very low response times. because nested data can become very deep. And in this case, you need just to be aware about the performance or the complexity. If you care about your developers, and so one developer can develop it in very complex way, and the other developer need to, or maybe to recreate this function or to try to understand how to figure out how this function is written. So ETLs, as I see it, from my experience, is much better in this case to handle this kind of complex, yes.
Okay, so the question that came is very similar to what I asked. What use cases, in what cases, sorry, you create such flattening and querying directly using Athena and Redshift?
Oh, good questions. Very good questions. It depends, and it depends on the scenario. So I will say the following, and this is what was actually in I found it is in an I actually. So we defined a process that need to be run daily process that need to be run, and the word we use here is enrich. We have had to bring some data lake or some solutions to be able to enrich natural intelligence main funnel with customer data. So for this kind of use case, it sounds like ETL is a good solution. But if you just need to analyze and make some ad hoc queries, then go ahead with the normal function. It can work. It can work for you quite well.
Okay, great. Okay, another question. Is there a way to analyze which collected data in key value data is dark and is not used, need to be eliminated from reporting? Interesting.
Why can I see this question?
One.
Where are these questions? Oh, is there a way to analyze which collected data in key value data is dark and not used and need to be eliminated from report? Oh, nice feature. I don't know. No, but it's important that sorry. Yes.
No, just it's interesting because what not used is very hard to define. Okay, we can see that there's reporters running on those fields, but it's very hard to know exactly what key values are actually used. The flatten would be easier because you can look at SQL actually coming. I don't know, Danny, do you have any idea?
As I said, it sounds like a good feature, but let's recall that when we speak about key values, we already speak about data that was normalized or was ETL'd, as I understand. So we don't need to worry about this data. It's not going to be dark data at any time, because we use the Parquet format, and we use partition tables, and data can run very good in this kind of structure. The idea of dark data is more when it's very hard to grab the data. And when we speak about key value and not nested data, is quite easy to take the data and no risk for dark data.
Yeah. So from the perspective of the data being dark, I'll reshape your answer. There's no, once it's a key value mapped to key value, it's actually not dark anymore because it's easily accessible. You can use very simple SQL to access this data. When it's nested,
Yes, you can
to
shift. Yes.
use more advanced.
Sure. Yes.
So it's moving stuff from the set part, I'd say, to the left, because it's actually making it more accessible. That's the entire idea here, right?
Right.
So it's not about the optimization of the data, about the accessibility. So the question of optimization is still interesting, but it's not the main. Let's say it's not the main feature of this mechanism. Okay. Another question is about. Okay. Let's see. Is the JSON, I'll just read it. Is the JSON format flexible? For instance, can we use a different format like key payout value $0.202 and the key value or flattening structures need to be predefined ahead, or there to be the ability to query data waste. So okay, it's two different JSON structures, the input, and I'll let you answer about the flattening and the key value, because I think it's the entire trick.
So we don't need. So this is the nice about that the system that we don't need to predefine ahead. As I said before, key values are dynamic. This is all the story about the idea of that system. It's a dynamic properties. The word dynamics means that we don't need to predefine. And especially if we look for a process that all the time knows to process dynamic properties with no predefined ahead. This is actually the process. So when we will need the definition for the new properties, only the flattened data. And what is special about these things now, that sometimes you even don't want to expose any new data unless you get the approval for that. This is also other aspects of the flattened data. So ETLs knows to process the data with no predefinition ahead. So, and data is already processed and persistent in data lakes, and you have the data there. But yet manager, from some reason, said, I don't want to expose the data yet. Why? Because I need to be prepared for other, in other system. Okay, no problem. So, and then the manager come and say, now I want to see the data in the flattened data, and that's it. We just take the simple command, the DDL, very simple DDL command, and add column, and that's it. And all is being connected silently.
Can you move to the slide? I'll answer a little bit an elaboration of that. Can you move to the slide of the JSON example? When we saw the map definition.
Not this one, this one?
Another one?
Another one?
No.
Oh, this one.
Oh, this one. Stay on the definition. The dynamic properties on the second line, okay, is a map string, okay? And I'm just clarifying it because the question was about the JSON, okay? And I think the rest of the flow makes it's important that we define the JSON is actually the same structure as we define this table. So the JSON itself, it has some kind of a section that is a map. Okay, it's a key and a value which are both string. And this is where it's a little bit, I wouldn't say limited, because you can describe everything with a map from string to string, okay? But it's like mapping of a key value structure, correct me if I'm wrong, Danny, key value structure in a JSON to, let's call it a map structure in a table. So do you have a JSON example of this event?
Yes.
You had it, right?
You see the black the black at the start of the slide?
So
This is a JSON line.
The black on the top, it's actually a so the dynamic properties, you have credit pass, no. Call duration, something. Payout, something. So it's actually a standard JSON with two strings, the key and the value, okay? The only thing we're saying here is that they're supposed to be strings, the key and the value. The key is always a string because it's JSON, and the value might be different types require to be a string like that. If we put a number instead of a string here, something would break, right? We'd have to do something and probably stuff wouldn't work here. Am I making sense?
Yes, it's making sense.
Okay. Okay, so this is the only, limitation here. And I'm pretty sure we can extend on that. If we want to have different types there, we might think of a couple of ways to do different types, because you can actually convert everything to a string, but we would need probably to write some code around it, which would be a little bit more complicated than the code that Danny showed. And this is part of the magic here, because it's really not that complicated to generate this output. And from I can tell you that from the perspective of our analysts, this is magic. Okay, instead of getting a nested structure with internals which are very complicated to handle, and doing all those unnesting or left joins, they're getting these flattened lines, which is very I would say natural for them to work with. And then the key value, I'm sorry. And then flattening is really like getting everything as easy as it can be. Okay, guys, I think we're done. Do you have any more questions? Last chance. Okay, I think we can call it a night. Thank you very much, Daniel. And as I said, all of the videos are uploaded to the Natural Intelligence YouTube channel. And I had a lot of fun in the last 5 meetings. And probably we'll do that again in the not so far future. Thank you. Great night.